So for question 2, part A and part B, you're able to know how to do those questions. But for part C, you seem to have a bit of trouble in terms of the mathematics of it. So let's go through this question. Relative atomic mass of copper is 63.54. Then you are to calculate for the relative abundance of its two isotopes, one with mass number 63 and the other one with mass number 65. Okay, so good thing you have done is that you're able to express the equation well. One thing you take note is that you need to label carefully what is the percentage abundance of each isotope over here. So one is copper with mass number 63, let it be, let's say, X%, and percentage abundance of 65 copper be 100 minus X%. Okay, relative abundance actually over here it just means the abundance in comparison with another percentage abundance. Okay, so that's why you see X% and 100 minus X% since there's only two isotopes. Okay, so over here you will have to express it in terms of a mathematics equation. Okay, so this is what you have done over here. I think the trouble is that you're trying to figure out how to basically deconstruct this mathematic equation. Okay, one tip over here is that you need to make sure these are expressed into 1 dp. It's a good habit because these are mass numbers. Okay, and most of these mass numbers usually you will want to express it to 1 dp. Okay, and at the end of the day what I want to do is that I want to make sure that everything of x, so whatever x, maybe 2x, 3x, all these numbered x, right, I want to accumulate on the left hand side. Whereas for the ones without x, which is basically a constant, should be all accumulated on the right hand side. Okay, so let's just break each number down. Okay, you want to break each number down into its decimal place. Okay, so over here 63 over 100 will have been 0.63. Try to express it in terms of 4SF for intermediate workings. Okay, for 1 minus x over 100, this one is a bit tricky. Okay, you can either go with 1 minus x over 100. Okay, because 100 over 100 is 1 and x over 100 is x over 100, or you can choose to multiply basically, okay, 65 times 100 and 65 times minus x. So this means you'll get this instead. Okay, so either way is correct. Okay, and then you can also actually when you cancel the terms out, right? Okay, when you cancel the terms out, actually you realize that it's actually okay, 65 minus 0.65 in this manner. Okay, we'll go with 1 minus x over 100 first. Okay, I just find that a lot easier, right? So 63.54. Okay, and this one will be 65.00 minus 0.6500x. Okay, so notice how all of them are expressed to 4SF as intermediate workings. Okay, so that is a habit you should do. And then once you accumulate everything, okay, so if I bring all the x's to the left hand side, all the other numbers to the right hand side, you'll eventually get this. So 0.65 minus 0.63 will give you 0.02000x. The other one would have been just, okay, 65 minus 63.54. Okay, that will give you 1.460. And then last but not least, you just need to calculate and then you'll receive this. Okay, and then your final answer just need to express this out. Okay, have an answer line. And then for copper 65, it would have been 100 minus 73. So there will be 27.0%. Okay, and that will be your final answer. If you want to know how to check, okay, the fact that your relative atomic mass is closest to 63, it probably means that there should be a greater percentage of copper with mass number 63, and that's what we have achieved over here. Okay.